All right, so instead of plugging in a number into function f, we got to plug in g of x squared minus 1. All right, so we're going to take g of x, this expression, plug it in for x right here in f of x. Okay, so it's x squared minus 1 right there, and then plus 2. Combine negative 1 and 2 together, and we get x squared plus 1. All right, so you're substituting one function into the other. That's it. Okay, the other way around, part B. G composed with f of x. First step I highly recommend is don't skip this step. Whatever's closest to x goes inside. And don't make this any more complicated than what you do if you plugged in a number. For example, if it said at this point g of 6, what would you do? You'd take 6 and you'd square it and you subtract 1. Well, you're not plugging in a number. You're plugging in f of x into that spot. That's all. So f of x, x plus 2, goes in right here. Okay, so you can jump to this step if you get it, or maybe you want the step in between because you actually could write f of x right there. All right, so x plus 2 squared minus 1. Expand it, FOIL it, and then do the algebra. Substitution is the tough part. This is new, might take a little while to get used to, but one function into the other is what's happening. So I expanded it here. It gives me x squared plus 4x plus 4. And I FOIL that. So there's the final answer, x squared plus 4x plus 3. Okay, last one, C, and then I'll have you try 11 to wrap it up for today. All right, so C, f composed with g of 2. So now we already have f composed with g of x from part A. So this is where we could take a shortcut. There's another way to do it. I crossed it out. I'll wait till tomorrow to show this approach, but this is probably best to use now because f composed with g of x was x squared plus 1 in A. The risky part of this approach is you got to be guaranteed that you did part A right. So that's why I want to show you another method tomorrow. Okay, but assuming we did part A right, I just rewrote it right here. Now I just got to plug in 2 in for x. Okay, so I plug in 2 for x, I get 2 squared plus 1, 5. And that's the answer. Alternative approach tomorrow. Okay. All right, that's enough for you to try 11. I know there's a square root in there, but just try the substitution. The simplifying is actually pretty easy for 11. Try A, B, and C. Give you about 2 minutes. Okay, here's f composed with g. So since g of x is g is closest to x, that goes inside. So now this function, this entire function, this whole radical goes in right here. So I have quantity squared, right? But that goes inside the quantity. So quantity squared plus 1. All right, squaring a radical, that's going to cancel and just give me x plus 2. And now we get x plus 3 for the answer. All right, B flip-flops this process. F goes inside, so now f goes into g. So now I take this entire expression, and this has to go right here under the radical. So everything's under the radical, like that. Right? X squared plus 1's there, and then I got the plus 2. All right, the parentheses are really just there for substitution purposes. There's really nothing to do. So I just add the 1 and the 2 to get x squared plus 3. Okay, I'm going to introduce you to that other approach here for part C. If you piggybacked off your answer from A, great. But what if you didn't do part A correct? I'm going to walk you through one other way you can do this. Okay, you can write this down or you can just watch. So 2 is closest to G. So what I did is just focus on finding G of 2. Piece of cake, right? All I got to do is go throw 2 in G of X. So I did that, found G of 2. gives me square root of 4, which is 2. So now I just replace g of 2 with what it's equal to, okay, which is 2. This problem has a lot of 2. It's probably not the best one to introduce this method with, but oh well. All right, so now I just focus on finding f of 2. I take 2, plug it in right here, 2 squared plus 1, and I get my answer of 5. Okay. All right, that's as far as we get here today. We'll pick up from there tomorrow. Okay.